Okay, so for the first question, as you quite rightfully said, you just change that sine cos, the cos and the sine, and we can change that sine to, that tan to sine x over cos x. Yeah.
Yeah.
And then plus. So let's look at the quadrants quickly. So this is 180 plus, 180 minus, 360 minus. So we see sines in this quadrant. I mean, yeah, 180 plus, and it's only tan is positive. So this becomes minus sine x. What you can do as well, if you forget the quadrants, is you can, as I said, you can give sine a value of 30, x a value of 30, and so you can see sine to 10 because you know that sine 30 is a half.
Yeah.
And you get minus a half when you put in sine to 10. So that helps to know that it's not minus sine a half, but it's minus sine x. You're just giving a value of x in order to kind of use your calculator. But they want to probably see the cost diagram, so you'll just write it here.
Okay.
Just and yeah, okay. Okay, and then time cos 90 minus x, again, give cos a value, give it a value of 30, and you get a half when you put a value. So then you know that that's the sine, because sine to a half, so sine x. So we're always doing our best to, when you see 90, to convert it to either sine or cos. So when you see cos 90, you know it's going to be converted to sine. And when you see the sine 90, you're converting it to cos. And then we, so we've got, now when it's at the bottom, if it's at the top of the bottom, it goes to, it can cancel with the top. So,
yeah.
I don't know if I'm explaining that properly. This is at the top, and if we look at the bottom, this is at the top of the bottom. So basically, they can exactly. And then these, well, this is still at the bottom, and this is at the top, and at the bottom. So it's like saying 1 over, and then these can cancel too.
Okay.
Because that's like cos over 1 sitting there at the bottom. And so we end up with 1 plus, and this is a negative, so it becomes actually minus sine squared x, which we then look at our special angle formulas, is cos 2x. But I'm just going to pause there so that we can write in our special angles. Okay, so here's our double angle formulas, but what I want to do quickly is just show you one of these ones, which is the cos 2a equals cos squared a minus sine squared a. Often this ends up in one of the questions being converted, because this can be factorized into cos. So this is cos a, because this looks a lot like x squared minus y squared. And so this can actually be cos a minus sine a. So when you factorize this, it would be x plus y and x minus y. And you can do this exactly the same way here. You say cos a plus sine a, and then cos a minus sine a. And yeah, so just keep this one in mind because it does sometimes come up. So we've got this we see is over here in our special angle formulas, which you have at the back. So when you are writing your exam, make sure that you just take that formula sheet and put it on the side so you don't have to keep going, flipping to the back. So have it next to you. And we can see that then this is actually can be simplified to cos 2a. Okay. 5.2. They want to, without the calculator, change this from sine squared 35 to cos squared 35. Well, we can already see that we were just talking about cos 2a. Okay, and how that is the same as this. So this could be a cos, we could turn it into cos 2 times 35, which would be cos 70. We just see, would that help us? Because this is 10. Okay, it could help us because this here, when we look at our 2 sine 2a is 2 sine a cos a. So this technically could be doubled. So we could take the 2 out and it would be 2 sine 10 cos 10, which could be then 2 times sine 2 times 10, which is 20. What we have then is 20 and 70 both add up to 90. So we're going to go ahead and do that and then see if we can simplify it further from there. So sine squared 35 is going to be, we said, cos 2 times 35. And then the second one, we're going to take it out and we're going to have it like 2 sine 10 cos 10, which we can then convert to, so we're going to keep this then as cos 70, and this is going to be 2 sine 20. Okay. Sine 20. Okay, now we're going to convert out one of these to, so cos 70 is sine 20. So we can just convert it to sine 20 over 2 sine 20, which is a half. Now, even though they said don't use your calculator, we haven't, but we can use it to check. So I'm just going to put that into the calculator just to see, because there's no memo for this. So this is, okay, so when I put it into my calculator, I get minus a half. So this is very instructive, and this is why we should always check, because when we change the answers, we need to look at where we put in our, when we put in our sine squared 35 minus cos squared 35. Cos 2a is cos squared 35 minus sine. So it's this one, but it's the other way around. So we need to actually take this, and if you multiply it by negative, if you times both sides by negative, you get negative cos 2a, and then you'll have a minus cos 2a plus sine 2a, which is sine 2a minus cos 2a, which is actually what we're looking. So this here is a negative, and a negative, and a negative, and a negative. So we need to check. Okay. Now, the 5.3 is we are given cos 26 equals m. Okay, so what we can do is we can draw a little triangle, which I'm going to do in red. And so we have 26 here. And they're telling us that it's equal to m. So we know that cos theta is equal to adjacent over hypotenuse. So if which means it could be, say, m over 1. Because m is the same as saying m over 1. So we then know that the adjacent value to the 26 is m, and the hypotenuse is going to be 1. And so that we work out the sine using Pythagoras. So we can say that we've got this side, so we draw it in here, is going to be 1, the square root of 1 squared, which is 1 minus m squared. So that's that other one. So they want 2 sine squared 77 in terms of m. Okay, so we look and we say, well, how am I going to convert this into something which has either 26 or this one has a 64 here? And how does 17? Well, we know that 77 is 90 minus 13. So that helps, because this could then be, say, cos squared 13. And the other thing we know is that 26 is double 13. So we can use that to try and figure out the final answer. Okay, so let's just write the 2 sine squared 77 as 2. Let's keep it in white. Okay. So we've got this, we're going to just write as 2 cos squared 13. Okay. Now what we see is that, okay, we know that 2 cos squared 13 minus 1 is cos 2a. So what we can do is, it's only this bit that applies, but what we could do is we could add the 1 to, because what we can do is we can say cos 2a plus 1 is equal to, so we take that 1 to the other side, 2 cos squared a. So that's what we're going to do. So we're going to say 2 cos squared 13 is going to be cos 2a, which is 2 times 13, and we'll just add 1. So we'll say cos 2 times 13 plus 1, which is equal to cos 26 plus 1. Well, we know cos 26 is m, so it's just equal to m plus 1. Okay, so I'm going to stop it there, and we will carry on with 5.4.